Thank you for standing by and welcome to the GF Business Webinar Series, GF at the Forefront of the Photonics and Packaging Revolution. At this time, all participants are in listen-only mode. After the speaker's presentation, there will be a question and answer session. To ask a question during this session, you'll need to press star 11 on your telephone. If your question has been answered and you'd like to remove yourself from the queue, simply press star 11 again. We ask that you please limit yourselves to one question each. As a reminder, today's program is being recorded. And now I'd like to introduce your host for today's program, Eric Chow, Head of Investor Relations. Please go ahead.
Thank you, Operator. Good morning, everyone, and welcome to GlobalFoundries Silicon Photonics and Advanced Packaging Investor Webinar, the second in our series to help you better understand the most exciting areas of our business. Today, we will be providing a business, technical, and strategy update on why we believe GF is at the forefront of the silicon photonics and advanced packaging revolution. We're excited to showcase how GlobalFoundries' differentiated platforms and high-performance interconnect technologies address the need for increasing levels of speed, efficiency, and scalability for next-generation data and connectivity applications. On the call with me today are Mike Hogan, Chief Business Officer, Greg Bartlett, Chief Technology Officer, and Kevin Sukup, Senior Vice President of our Silicon Photonics business. Today's slide presentation, along with a recording of the call, will be made available on our Investor Relations webpage. Certain statements on today's call may be deemed to be forward-looking statements. Such statements can be identified by terms such as believe, expect, intend, anticipate, and may, or by the use of the future tense. You should not place undue reliance on forward-looking statements. Actual results may differ materially from these forward-looking statements, and we do not undertake any obligation to update any forward-looking statements we make today. For more information about factors that may cause actual results to differ materially from forward-looking statements, please refer to risks and uncertainties described in our SEC filings, including in sections under the caption Risk Factors in our annual report on Form 20-F and in any current reports on Form 6-K furnished with the SEC. At the conclusion of our prepared presentation, we will open the call for questions with Mike, Greg, and Kevin. We request that you please limit yourself to one question and focus the scope of your question to the topics discussed in today's webinar. I'll now turn the call over to Mike.
Thank you, Eric. AI has fundamentally changed the performance requirements of the data center. In this new era, optical interconnect is no longer optional. It is required. Compute availability and capability is no longer the bottleneck. High speed, low latency, power efficient connectivity is. Let me introduce one term that matters a lot for AI data centers: east-west traffic. At a high level, east-west traffic simply means data moving between machines inside the data center rather than in and out of the data center. Traditional applications were dominated by north-south traffic, users talking to servers. AI flips that model. Most of the data now moves laterally between compute resources and the switch fabrics that interconnect them. In AI systems, GPUs and XPUs must constantly exchange data to train and run large models. That lateral machine-to-machine communication is what now dominates network load. This shift to what is commonly referred to as scale-out and scale-up networking exposes multiple system bottlenecks and forces a reset towards maximizing system-level efficiency on multiple levels. At the same time, power consumption is approaching 1,000 terawatt hours annually. When power becomes the constraint, the industry no longer optimizes individual components, it optimizes entire systems. Interconnect efficiency becomes critical. This criticality becomes more intense as workloads shift further to inference, where the cost per token becomes a key parameter for the sustainability of AI business models. Interconnect efficiency can be summed up in four simple constructs. Reach, the physical limits of data transmission. Bandwidth density, the bits per unit area that can be delivered to a processor or switch. Energy efficiency, the bits per unit of energy that can be transmitted across a link. And ultimately, compute efficiency, the overall utilization rate one can extract from a compute resource, all at the right total cost. This is where physics takes over. Using copper becomes fundamentally challenged beyond 200G per lane. It cannot economically support the reach, bandwidth density, or power efficiency required for sustained GPU to GPU communication at scale. The cost and power required in terms of complex DSP techniques used to extract data from noise reaches a point of diminishing returns for both power and cost. While the physical properties of copper attenuate the signal to such an extent, no amount of retiming and retransmission can address this ever-shrinking reach. Optical networking scales cleanly across the dimensions that matter for east-west traffic: reach across racks, bandwidth density within packages, energy efficiency, and ultimately, compute utilization. That is why optical enables XPU utilization to move from as low as mid-teens to north of 80%. This is not a GF position, but one broadly embraced by the industry. Across compute vendors, network leaders, and silicon suppliers, there is strong alignment. Scaling east-west traffic requires optical interconnect. These are current generation architectural decisions, not future roadmaps. And while the debate will no doubt continue on the growth of specific form factors, such as pluggables, onboard optics, and co-packaged optics, the broader direction is clear. We are entering the optical era. So let me now hand things over to Kevin Sukup to dive deeper.
Thank you, Mike. Now let's talk about how GF is positioned for continued growth in this exciting market. At a high level, we believe our advantage comes from combining technology leadership, deep design support and ecosystem, and global manufacturing scale to enable our customers to rapidly bring their industry-leading products to market. First, on technology leadership. With more than a decade leading the industry in silicon photonics research and development, GF offers an unmatched silicon photonics device portfolio, including modulators, broadband couplers, and advanced integration features such as through-silicon vias. This suite of building blocks comes fully characterized and is engineered as part of a highly scalable platform. Second, design, support, and ecosystem. We don't just manufacture wafers, we actively partner with customers. We have applied the rigor and learning of decades of best practices in microelectronics to this new field to establish a robust enablement environment, including the industry's leading silicon photonics PDK. Our in-house turnkey design capabilities, combined with strategic partners across EDA, test, fiber, and assembly, significantly reduce customer time to market and execution risk. Third, global footprint and scale. We are manufacturing silicon photonics at scale on both 300mm and 200mm platforms, with production in New York and Singapore. This dual region capability matters deeply to our customers, all of whom need supply chain resilience, geographic redundancy, and trusted manufacturing, with the ability to rapidly scale to meet the requirements of this fast-growing market. Taken together, we believe GF enables accelerated time to market for highly integrated electro-optical solutions across every AI data center application. This slide shows how GF's platforms translate into real products our customers are making across every major optical use case. We support long-range scale-out and scale-up architectures, each with different requirements for bandwidth, latency, and reach. For long-range and coherent applications, we are shipping into 400G and 800G ZR+ solutions, as well as 1.6 terabit coherent interface modules. In scale-out data center networks, we're enabling high bandwidth, low loss links with DR4 and DR8 architectures, scaling to 1.6T, 3.2T, and beyond. And for scale-up systems, where latency and radix are critical, we have enabled bidirectional coarse and dense wave division multiplexing optical engines for our customers using micro-ring modulator technology. As the first to market to demonstrate the manufacturability of photonic resonant structures and the viability of DWDM architectures, GF continues to lead the industry roadmap. We have deliberately built a broad portfolio that supports the full range of pluggable and co-packaged optics, which we believe enables GF to support today's AI data centers, but also provides a uniquely differentiated roadmap to support the needs of tomorrow. The strongest validation of our strategy comes directly from our customers. Across networking, optical systems, and data center infrastructure leaders, the message is consistent. GF is a trusted development partner and a critical supplier. Customers highlight the robustness of our silicon photonics platform and the breadth of device and fiber coupling options. Others emphasize GF's execution, our ability to take silicon photonics from development into high-volume manufacturing with industry-leading quality and yield. Customers see GF as a long-term partner, one that can push the limits of what silicon photonics can deliver as AI workloads continue to scale. Late last year, GF made targeted acquisitions that accelerate both our technology roadmap and our revenue trajectory. On the left, you see the acquisition of AMF, which expands our manufacturing scale and geographic reach, accelerating our Singapore production capacity and immediately broadening our customer base. These new customers are not only driving demand for GF silicon photonics on a global basis, but they are also engaging on GF's leading silicon germanium and FDX technologies to support their solutions. As we integrate AMF fully into GF, we expect to unlock further revenue and cost synergies, as well as enrich our roadmap via the establishment of a deep center of excellence in Singapore in partnership with the Institute of Microelectronics. On the right, you see the acquisition of Infinilink, a highly specialized team of designers based in Cairo, Egypt, which deepens our differentiated IP and design services. This brings in advanced photonics control, modulator enhancement IP, and system-level expertise that enhances customer designs end-to-end. The Infinilink team is already engaged in supporting our customers to accelerate their designs and break new performance barriers, as well as pushing our roadmap further through new design innovations. Together, these acquisitions are not just additive, they are multipliers, accelerating time to revenue growth in both the near term and long term, while strengthening GF's long-term competitive moat. I'll close this section by stepping back and looking at the big picture. We believe GF is innovating across all three dimensions that matter in optical networking: bitrate per lane, lanes per fiber, and overall system radix. This multi-dimensional approach is essential as the industry pushes beyond 1.6 terabits per second in pluggable applications and beyond 14.4 terabits per second in CPO applications. This innovation extends beyond the wafer and into advanced packaging of the optical module. We are doing this leveraging a unique combination of manufacturing experience, technical innovation, optical know-how, and in-house design expertise. Driving innovation in all three vectors enables us to maintain our lead in optical networking, but also helps us extend into new applications like optical circuit switching, optical compute, and quantum interconnects. The key takeaway is this: GF is not chasing a single product cycle. We're building a durable, extendable platform that scales with AI, data center, and advanced computing demands over the next decade. That foundation, combined with manufacturing scale, ecosystem depth, and customer trust, positions GlobalFoundries to lead as silicon photonics becomes core infrastructure for AI. I'll now turn it over to Greg to talk about our advanced packaging capabilities, which are critical enablers for innovation across these three vectors.
Thanks, Kevin. If we return to co-packaged optics, the heart of the CPO solution is the optical module, which integrates three components: an electronic IC or EIC, a photonic IC or PIC, and the optical interface for the fiber coupling to the PIC. The key attributes of a CPO solution are the performance specs, specifically the high data rates closely coupled to the compute element, optimizing data bandwidth and reducing power. The integration of the EIC and PIC through vertical stacking reduces the footprint while delivering this improved performance and reduced power. Because this solution brings electronics and optics into a single module and requires a wafer-level detachable fiber coupling process, this packaging solution needs to bridge the world of electronic packaging with optics. We believe this capability is the most important ingredient to scale CPO solutions to high-volume manufacturing, achieve high yield rates, and thus the crossover performance and cost figures of merit that will ensure CPO's broad adoption. We believe that no single company other than GF brings these together all under one roof. To solve this challenge for our customers, GF launched plans for our silicon photonics and advanced packaging facility in 2025 in Malta, New York, to establish high-volume manufacturing capability to support the CPO ramp. The result of this investment is expected to deliver a fully integrated silicon photonics production flow from silicon substrate to known good optical modules. This capability will dramatically shorten the manufacturing cycle time and also provide rapid turnaround from wafer fabrication to full module yield, all under one roof. The optical module business requires a complex set of components integrated at very high yield and low cost. GF has worked with partners across the entire supply chain, from design and IP to fiber attached partners to test platforms, and even universities with critical infrastructure to enable development of next generation capabilities. And as we introduce highly specialized materials for 400 gigabit per second modulators, such as barium titanate, thin film lithium niobate, indium phosphide, or polymer-based solutions to our supply chain, you will see additional categories and logos as we continue to build out our ecosystem. And while we're very excited about the roadmap for silicon photonics and the differentiated solutions we are building, this is just the beginning. Before turning this back over to Mike, I want to close by providing a preview of some of the other use cases of advanced packaging that are becoming differentiation multipliers, enabling new combinations of technology in 3D structures that make new applications possible. This includes wafer-to-wafer bonding solutions that are already qualified and running for both silicon photonics and RF-SOI. The silicon photonics application is a fusion bonded solution of an EIC wafer to a PIC wafer, one of the key enablers for CPO. The RF-SOI solution is bonding a pair of our most advanced 9SW RF switch platform wafers, which can reduce the effective die size by as much as 45%. In addition, we are actively developing solutions like bonding a silicon germanium heterojunction bipolar transistor, or HBT, to our ultra-low power FDX platform. This delivers very high RF performance and ultra-low power without compromise for TIA and drivers in the data center. In addition, we have demonstrated high yield bonding of gallium nitride micro LEDs to our FDX backplane as key enablers for displays, and potentially as a way to an ultra-high bandwidth link between GPU and HBM to break through the memory wall in data centers. The roadmap is broad. We have many new applications under development, such as FinFET bonding for image sensors and gallium nitride on BCD for high power delivery solutions. The key takeaway here is that through 3D and heterogeneous integration innovation, we create combinations of technologies across our entire portfolio that would be impossible to achieve through monolithic integration. We believe this allows GF to enable our customers with highly differentiated solutions, and we are able to do so with the scale and maturity of a world-class manufacturing partner, including the essential enablement and application design kits that accelerate our customers' time to market. Back to Mike to talk about the market opportunity.
Thanks, Greg. As XPU to XPU traffic becomes the dominant workload in AI data centers, optical interconnect transitions from a long-haul solution to a core compute connectivity layer that scales directly with AI compute deployment. GlobalFoundries is scaling within existing cleanroom space, supported by strong U.S. and Singapore government partnerships that accelerate at-scale deployment of silicon photonics. with excellent capital efficiency and target returns. GF's geographically diverse manufacturing footprint, as well as our ability to service the market with multiple generations of solutions across 200 millimeter and 300 millimeter technologies, is a clear advantage for our customers looking to ramp quickly to meet this explosive increase in demand. By 2030, GF's serviceable addressable market in communications, infrastructure, and data center more than doubles to approximately $11 billion. With our broad portfolio of solutions, we believe we are well placed to grow as fast as, and likely faster than, the overall market. Within the broader CI&D landscape, the optical networking SAM more than quintuples over the same time period. Here, GF participates across silicon photonics, silicon germanium, and FDX drivers, and advanced packaging, capturing value from pluggable transceivers to co-packaged optics across long-haul, scale-out, and scale-up AI systems. Zooming into silicon photonics specifically, revenue doubled in 2025, is set to nearly double again in 2026, and we believe shows a clear line of sight to a $1 billion plus run rate by the end of 2028. All while our revenue per dollar of incremental CapEx is meaningfully improved through our investments in silicon photonics, building upon our existing factory footprint and supported by our strong government investment partnerships. In summary, GF believes XPU to XPU traffic is now the defining workload of the AI data center. Optical interconnect is the only scalable answer, and we believe GlobalFoundries is uniquely positioned to lead this transition. With that, I'd like to hand it over to Eric.
Thanks, Mike. Before we open the call to questions, friendly reminder to please keep the scope of your questions to the topics from today's presentation. We will be happy to address near-term questions about the business after we report Q1 earnings in May. I will also ask you to limit yourself to one question. Finally, please note that we will be hosting an Investor Day on Thursday, May 7th in New York City. This will be our first full in-person investor event since 2022, and our lineup of C-level executives will provide an update on the company's latest technical, strategic, and financial opportunities. We look forward to sharing with you our refreshed story, and I hope to see you there. Now for Q&A. Operator?
Certainly. And our first question for today comes from the line of Matthew Bryson from Wedbush Securities. Your question, please.
Yeah, thanks so much for taking my question. And thanks for hosting this. One of your competitors talks to having over 80% of the silicon photonics market today, but you have very similar revenues to them. It seems like you have at least similar trajectory into 2027. Can you maybe try to explain the discrepancy in their view versus how GlobalFoundries sees things, and kind of more broadly, how might your platform approach to silicon photonics versus Tower's more customized solution set play into this perceived difference? Thanks.
Yeah, Matt, it's Mike. Thanks for the question. Let me just put some framing and some context around how we think about where we are in silicon photonics. You can talk to the Tower about what they think, but I'll give you our perspective, and then I'll invite Kevin to maybe double click. I think just simply put, we think we're the largest player in silicon photonics, full stop. We've built that position based on a decade of sustained investment and benefited from the deep customer and partner learning cycles that go along with that, and just generally have, benefited from a lot of time over target to feel like we have the largest market share of all the pure play silicon photonic foundries. Not to put too fine a point on it, but we think that equals, greater than $1 billion of investment over this last decade. And we've done it in a way that's leveraged some advantaged 45 nanometer and 300 millimeter ability to scale in terms of how we bring that technology to market. So results clear. We're the leaders in this technology, both in terms of technology and share. And, our reputation, it goes beyond, a particular form factor like pluggables. It's really about the optics, and the optics are inevitable. So today we lead in pluggables because pluggables is most of the market, but we expect as the market transitions to near package and co-package optics, we will lead as well. And it's really based on, think about three pillars. At the tech level, we support 100 and 200 gigabit per lambda today. We have 400 on the roadmap and a pathway to 800 and beyond. We've demonstrated leadership in both CWDM and I think we're the first to demonstrate DWDM capability. We've got expertise in nonlinear optical materials, advanced 3D packaging. Secondarily, at the ecosystem level, when you've been involved for this long, you really just develop very deep relationships with best-in-class EDA providers like Cadence and Synopsys. So you have a full flow, microelectronics-like PDK experience for the customer that includes, full system optical simulation for first-time right silicon. And we've also built deep partnerships with folks like Senko, Corning, Paramount on the fiber attach side, and key players in the OSAT world like ASE. So, the final, pillar of this is manufacturing at scale. We are the only ones supporting customers at both 200 millimeter and 300 millimeter, and we're benefiting from some of the most advanced etch and lithography tooling that we bring to bear in that market. So, we've got a roadmap and a capability that's been designed from the get-go for supporting reliable volume manufacturing, and that's why we believe we have leading market share, and we'll continue to do so. But I'll let Kevin double-click.
Yeah, thanks, Mike, and thanks for the question. Maybe I'll just add a couple more details, and I'll continue with that framing around technology, ecosystem, and manufacturing. On the technology side, GF supports, as we showed, quite a wide variety of applications, so it doesn't easily synthesize into a simple set of figures. But on the wafer side, it comes down to our ability to build key active photonic devices like modulators, photodiodes, multiplexers, demultiplexers with the best performance. Our ability to lead innovation in advanced architectures. For example, GF was the first to market with 8 and 16 lambda bidirectional DWDM. And then on the packaging side, as we extend the business into CPO, on the packaging side, we offer high-density TSVs to transfer power and signal, multiple ways to attach the electrical IC, and a cavity-based structure used to bond lasers, micro-optics for fiber attach, or other new devices. On the ecosystem topic, Mike mentioned the PDKs. Look, we have fully characterized device libraries, and we have pre-silicon modeling capability so that our customers can be first time right with their designs into GF. So, in short, we help our customers build their designs and close their link budgets. On the manufacturing side, the 300 millimeter platform runs in the same fab that we run 12 nanometer FinFET. This advanced technology, it's a fully automated fab, excellent equipment and process control, and that allows us to deliver superior device performance with these photonic structures. And as a result, kind of in summary, 4 out of 5 of the top pluggable transceiver players are engaged with GF, as are key switch and GPU providers for co-packaged optics.
Awesome. Thank you so much.
Thank you. And our next question comes from the line of Krish Sankar from TD Cowen. Your question, please.
Yeah, hi. Thanks for taking my question, and thanks for this very informative webinar. I had a question for Kevin. From the prior question on Tower, I had a question on the other foundry, TSMC. How does GlobalFoundries technology for CPO compare to TSM's advanced silicon photonics and CPO platform? I believe they call it the COUP technology. So any color comparison and contrasting would be very helpful. Thank you.
Sure. And let me hand it to Greg as well to give his perspective. But I'd say, first and foremost, we start with a pick first mindset, and that goes into the way we approach co-packaged optics. This is not an enabler. This is a differentiator that helps unlock the full capability in an AI data center.
Yeah, thanks, Kevin. And going back to one of the slides that Kevin covered, it's not just photonics, it's optics as a science. That's where we start. And Kevin said the right first thought approach that we take, that it is thinking about a pick first approach. It's not about an optical I/O. The photonic IC plays a pivotal role in successful data transmissions and manipulation of that optical path. The best example of that is we think about broadband from the start. So as Kevin mentioned already, we have supported CWDM and DWDM from the start. That means that optical components, like being able to read in 8 lambdas on an individual fiber and passively mux and demux that, are important qualified devices in the library. We feel like we're the only ones that have such a rich library of those, whether it's 4, 8, 16, or even 32 wavelengths of light. Of course, moving to DWDM is a huge beachfront density improvement. It also applies to the fiber coupling scheme. We're not doing fiber grading couplers on there. We are, in fact, using the elements that from our partners in our ecosystem, specifically Corning, Senko, and Terramount. All of those solutions are not single lambda only, but support full DWDM capabilities. And maybe just as an aside, we talk about the roadmap for advanced materials going to 400 gig and beyond, where things like thin film lithium niobate, barium titanate. We also know that DWDM is a paradigm shift in being able to have really, really good beachfront density and still have very high bandwidth there. So because we have been over target for quite a long time, we have seen how data center architectures continue to evolve, year by year, and we have been doing work on this pick first mindset from the very start, knowing that each customer, each generation of products may have different form factor configurations. So as such, things as mundane as do you have bump, micro bump, or copper hybrid bonding. We support all of those form factors. So it really goes to the breadth and depth of the overall solutions that we offer in the portfolio on there. It also goes to the optical module, right? As Kevin highlighted, we do believe that this is an important extension of our manufacturing capability, not just the wafer fabrication, but the conversion of that into a known good optical module. We are very much in support of an open ecosystem. In fact, people designing in a TSMC EIC, we welcome those wafers into our optical module and believe that our photonic ICs can also be integrated into their ecosystem as well. So we believe that for the benefit of the hyperscalers and our customers, having that open ecosystem in both directions is a critical part of our compatibility across a broad set of solutions there. So ultimately, we do believe that there will emerge some standards, and I think we're firmly in support of that. Meanwhile, while we do maintain great flexibility for form factors there, and then maybe I'll just close with, I do think it's important to pay attention to the transition from single wavelength solutions that dominate today to the DWDM architectures.
Got it. Very helpful. Thanks a lot, Greg. Thanks, Kevin.
Thank you. And our next question comes from the line of Kevin Kerrigan from Jefferies. Your question, please.
Yeah. Hey, team. I appreciate you guys hosting this webinar. You talked about being the largest player in silicon photonics. Can you just talk more about market share and what you think your market share is today, especially compared to your competitors, and where you think it can head over the next, let's say, 3 to 5 years?
Yeah, Kevin, thanks. It's Mike. Look, I mean, just to put some round figures around it, we think we are the market leader in silicon photonics foundry. We certainly believe that with the addition of AMF, it's sort of beyond question that we're the number one guy in the market. That's against what we see as a SAM of $1 billion. So that's where we are today. Going forward, we do believe that optical networking SAM will grow something like 40% CAGR through the end of this decade, and expect that our share will actually continue to grow through that time period. And it's really all about, our ability to scale manufacturing,
deliver reliable solutions, and the ability to support really any form factor. Today, the market's all about pluggables, and that's, as Kevin mentioned, that's why we've got engagements with 4 of the top 5. But as it transitions to CPO, we feel we'll be even better positioned to take advantage of those scale-up networks as those market transitions happen. So, hopefully that'll give you some indication of how we think about market share and where the market share goes.
Yeah, that's perfect. I appreciate that answer. Okay, thanks, guys.
Thank you. And our next question comes from the line of Harlan Sur from J.P. Morgan. Your question, please.
Hey, good afternoon. Thanks for hosting this event. At the time of the AMF acquisition, November of last year, I think you guys had anticipated driving your SiPho CPO business to $1 billion revenue level in calendar 30, right? In the most recent earnings, and you guys reaffirmed that today, you pulled that forward saying that you'll be driving $1 billion annualized run rate sometime in 2028, which means $1 billion plus in 29. So a year ahead of your prior expectations, that's a 50% growth CAGR now through 29. That's obviously faster than the SAM opportunity that you outlined in your slide deck. What's driving the faster growth profile? You talked about share, but I'm wondering if you can also touch upon, is it more rapid adoption of CPO? Is it stronger growth in just the overall optical port counts demanded by the market? Is it a combination of all of the above? Any color would be great.
Yeah, thanks, Harlan. I mean, first and foremost, this is an oversubscribed corridor, right? So we are adding capacity to meet demand because that growth rate, like you mentioned, is really significant. So, that $1 billion plus run rate by the end of 28 is actually supported by real revenue customers who've got traction, sort of all competing for that oversubscribed corridor. So that sets up, quite favorably. But, we feel good about our ability to scale, and we've made the investments to meet that demand. With respect to where it comes from, if we have to call it today, we model about maybe a third of that revenue in 28 being in the CPO space versus pluggables. And clearly CPO in the scale-up sense is going to be an accelerant to the market. But honestly, if CPO takes a little longer, we still stick by that number. We'll just ship more pluggables as CPO, catches up. And honestly, it could go the other way as well, where CPO could be bigger, sooner, bigger, faster. And that scale-up networking could actually drive that percentage of that $1 billion plus run rate, up above 1/3. So that's why, to your point, we've pulled in the expectation of instead of $1 billion plus revenue in 2030, it's really a $1 billion plus run rate before the end of 2028.
Very helpful. Thank you.
Thank you. And our next question comes from the line of Mehdi Hosseini from Susquehanna International Group. Your question, please.
Yes, thanks for taking my question. I feel like we could spend the entire day discussing and debating photonics. So in that context, I want to actually switch gears and double-click on advanced packaging. Can you help me understand your opportunities as it relates to advanced packaging and tests outside of optical? And it would be great, actually, if you could add some TAM numbers to it.
Yeah, Mehdi, hi, this is Greg. Thanks for the question. You saw some of the development and things that we already have in production. One of those, as I mentioned in my prepared remarks, was around the RF-SOI space, which brings together, 2 of our flagship 9SW switch wafers for bonding. None of these are likely to grow at the rate that the optical module for CPO does in that kind of time frame. But for us, what we have is a matrix of all of our product lines with their key platforms and innovation around how those combinations bring solutions together. So, one of the things that I highlighted in my prepared remarks was bonding an HBT to an ultra-low power FDX wafer for TIAs and drivers, but we also see those same applications, for example, in a telecommunications base station. That's not at the numbers that CPO is going to be. So I don't think we've got, a clear, here's what the TAM is going to be for each of these. Each of our individual product lines has these building blocks that bring combinations together on there. Our job is really to build the fabric, if you will, that allows each of those product lines to innovate in the end applications. And we literally, to your point, we could go on for an hour about all the end market applications that can be brought together, whether it's imaging or BCD and, GaN technologies. So I think it's, stay tuned as you'll see each of those product lines unfold a series of announcements in the coming years.
And Mehdi, and I would only add, what makes us most excited about advanced packaging is, we're focused completely on differentiated solutions. And the ability to take a differentiated solution and combine it with another differentiated solution through advanced packaging is sort of an exponential on differentiation. So as Greg said, we're not ready to put a particular TAM on that, but it actually is a force multiplier for our R&D investments to be able to deliver them combinatorially, not just sort of, in market by market. So it's a very exciting time for us in advanced packaging, and we expect more to come on that front.
Got it. Thank you.
Thank you. And this does conclude the question and answer session of today's program. I'd like to hand the program back to Eric Chow for any further remarks.
Thank you, Jonathan. And thank you, everyone, for joining today. We look forward to seeing you at our Investor Day on May 7th in New York City. Thank you.
Thank you, ladies and gentlemen, for your participation in today's conference. This does conclude the program. You may now disconnect. Good day.